So, okay, I think we can start.
Okay, I think we're...
Achim.
Hello, everybody. I think we start. I'm architect. I'm the technical director in Germany. And that's all I can say in French because...
Do this in English here. We want to speak about v13, highlights of upgrade training of v13. My first question to you is, who works with v13 of you? Okay, 4, 5, 6. One more? No? Okay. v12. Fine. v11. 2004. Version 3 of 4D? Okay, it's a joke. So, what we want to do today, we want to have a small introduction. We want to speak about storing data outside of records, improvement of the maintenance and security center, picture management in 4D, and print preview using XPS. If someone of you is ready to join my session tomorrow, we will speak tomorrow about all new in list boxes, about the HTTP client, new events and database methods in 4D, and structure access. But that's for tomorrow. At first, if you convert your database from 2004 or older versions, this is a so-called big conversion. Why a big conversion? Because with v11, the whole database kernel and the database engine is written by new. And so all comes from older versions from 2004 or before is a big conversion. A lot of reorganization inside the structure and inside the data file. If you do a conversion from v11 or v12 to v13, it's only a so-called small conversion because the rewriting has been done in v11 and v12 and v13 are already rewritten. Only small conversion has to be made. Small conversions like you maybe know from 6.7 to 6.8 or so. But there's only one way to convert your database correctly. Maybe there will be many ways, but for me there's only one way to how you can do it the correct way. First, if you would come from older versions than 2004, from 2003 or 6.8 or what else, please do a first conversion to 2004. Not directly to v11 or later to 2004, and then take tools 2004 and repair and compact, not only data file, but also the structure file. And only if this works, it is okay. And please don't simply verify. Verify is a fast algorithm, but I will say a weak algorithm, not so strong as repairing and compacting. And if there will be any problems concerning your structure that cannot be fixed by repairing with 4D tools, please use 4D Insider. 4D Insider runs in 2004, and then put your database from the old one into a new database, and that's it. Or maybe use sanity check or data check. If you are not so familiar using 4D Insider, there has been a good technical note some years ago from me, how to repair databases by using 4D Insider. It's not really a repair, but it's a create by new, because 4D Insider was never thought to be a tool to repair database, but it should create a new database. And in this case, if there have been errors in the old, the errors normally should not be there anymore. And all I said now and much more you can find in a very good document, conversion guide to v11 sql.pdf. You will find it in the documentation center on the v11 pages of the documentation center. You will not find it in the v13 or v12, but in the v11 pages. And last but not least, a tip from me, don't waste too much time to repair a corrupted data file or corrupted indexes or what else. Simply export your data in v2004, and if you have converted the structure into v11, 12, 13, re-import your data there. So you have not to struggle with any repair. And at the end of the introduction part, some system requirements. It's easy now because Windows and Macintosh, it's obviously the same. For both platforms, we need a minimum of Intel Core Duo or better, a minimum of 2 GB RAM, but honestly, what's 2 GB? RAM costs nothing, and RAM can only be replaced by RAM, by more RAM. Screen resolution, okay. Windows operating system, a minimum of XP, Vista, Windows 7 or more. And from next week, also Windows 8 and Windows 12 Server. And on the Macintosh side, 10.6.8 or more. And the only thing is, if you use XP, there will be some things that 40v13 has integrated some techniques like XPS or integrated web area. Not integrated web area, integrated WebKit, yes. That's not supported with XP, only supported with Vista or higher. So, first, up to v2004, the big data, and big data is for me a blob, picture, or text, was always stored with a record, inside the record. So if you have stored this in the records, and there was no other chance, yes, there was another chance, but I will tell you later, there was no chance. So you got big records, and you have long loading times and transmission over the network. There has been an old trick, very shortly, to do manual one-to-one relation. Who of you has used something like this? Okay, only one, fine. To get the big data outside and to have faster loading times. And only if you used, if you activated the relation by programming, relate when you relate man, and so you loaded the big data. In v13, the big data is always stored outside the record. Outside the record, and here you see a picture from the database property dialog. And, oops. And you could define if you want not only to, so you always store the data outside the record, but you could additionally define if the record is stored outside the record but in the data file, or outside the record and outside the data file. We will see it in a sample, in the next sample. And over that, you can define which size of external data will be stored outside or maybe inside. Let me see, you have pictures of 2 megabyte. 2 megabyte I want to store outside. But if you maybe have a thumbnail of 2K, maybe it is faster to store it with a record and to send it over the network than to have a second disk access. Okay? So this is a kind of automatic relation, and the reason for this is to make queries faster, queries that will not use the index. So like a multi-level query or like sequential queries. In this case, 4D only loads the main part of the record and not the big data. The overall reason was not to have a faster record loading at all. because changing concerning the network transfer and so on helped in v11, 12, 13 to have a faster record loading at all. And if your old trick is still needed, only one guy has used this trick, honestly, you have to check. Check it with your data and you will see if it is needed or not. Or not with your data, but with the data of the customer. If it is the database on the customer side, it depends on the structure of the data of the customer, not only your test data. So let's have a look at the first sample. Yes. So the first sample here shall be a kind of picture database, a very simple structure. I not use the old trick here. I have a picture field in my record, and the goal is to get pictures from the picture data from a camera on my desktop, and to put these pictures inside the database application. So let's next have a look into the package of this application, and here we already have some pictures that we want to bring. Here, some pictures, you see some JPEGs that we want to bring into the database. And we will do it by drag and drop onto the 4D icon. And wrong 4D version. Sorry for that. This one over there. Now we should have some records inside the database. Once more. Yes. Now it worked. You see, we have the pictures inside. And it is done by the onDrop method. And the onDrop method we will find over here. Database method onDrop. And this is, it's big enough that you can see it? Okay. So some things all done using the pasteboard, and this code here is the old code like you did it in v11 or v12. We can delete this code and take the modern code. I will tell it and move it over there. So, and what this modern code does is simply the drag and drop gets all the picture paths into the pasteboard. We read the single path, put it into an array till the pasteboard is empty, till all pictures are written out from the pasteboard, and then we create in a for loop over the array a record. We read the picture file from disk. We get the picture file name that's new. No more string operations to get the to extract from the end of the path the name of the picture. Put it over there, and also the picture size. Assign the picture and save it. And this would be the modern code to do it. Next, we want to save time. We leave the pictures inside. Normally, I wanted to delete and to show the new code, but it's not so important. Let's save time, I think. we have 4 records over there. Now we want to have a look at the Maintenance and Security Center. And you see we have a filled data file with nearly 10 megabyte, and for 4 pictures, a lot of stuff, and mighty records, and much load over the network, and all these things. Next, we go to the structure file. We want to bring these pictures out of the database. And you see, like I told you, the v13, in each case, no more stores the big data inside the record like the v2004 or earlier, but outside the record, but inside the data file. And now we want to to bring all these pictures outside of the data file by simply switching this option. And then I have prepared a method to do this. The method store external. We have a short look at this method. And in a loop of all of the records, I look with my 4D folder, and I want to put all the pictures directly inside the 4D database folder beside the structure file. And I set the external data path. In other words, I will tell the picture field where the external picture can be found. This information is stored inside the picture field. And then I make a dummy change. You know these kinds of dummy changes that when I save the record, the path to the external file is done. Save record, next record, and so on. And we want to run this method. And if we run this method, you see the records are still there. And the pictures are still there. And if we have a look at the Maintenance and Security Center, they're gone. They are outside. And we want to have a look into the folder now. Here we are. I have a folder. I named the folder External Pictures, and here the pictures, the same pictures than before, are stored by programming outside the data file. If we now, next we should normally compress the data file to save the space. It's not so important here. I think every one of you can imagine that it works. And but be aware, don't rename this folder. This could be a con, because all what the user sees, he can destroy, I would say. If he renames external pictures to internal pictures, your database will no more find your pictures, because the path does no more works. Inside the database, in the picture field, you have the folder name external picture stored, and if it is renamed, you will no more find it. And the next thing to keep in mind is, if we delete all the records here, we have an empty database, but the external pictures are still there. If you delete the pictures inside the database, it's your responsibility to delete the pictures also outside the database in the external folder. There is an automatic link telling here is my record, there you will find the picture. But there's no automatism. If I delete this record, also the picture is deleted. You have to do it by yourself. Okay, back to the slides. What else to tell? Backup and restore also works for external data. If you back up your external data, also the folder with the picture is stored, and if you make a restore and integrate the log file, it is all restored so that you go on working. If someone maybe deletes the external folder and your database doesn't work anymore, simply restore and all goes on. What also works is the SQL replication and synchronization with external data. If you do this between several databases, between a company and several subs, also this will work. And a very important thing is, in this case, there is no record locking, like you note from 4D. Why? It's easy. You have no records outside the database. These are external files. And what to do, or what can happen if there's no automatic record locking? Imagine two of your processes want to do something with the pictures on the disk. You have to pay attention, maybe by using semaphores. Or imagine an external application changes your picture and you want to load the picture. How can you know if the external application has opened this picture? No chance. You load the picture that can be modified for the moment. So what can you do? You can compare the pictures. Okay, the first important point was use semaphores to avoid this if you can, but you cannot use semaphores to watch external applications like Photoshop if you open a picture in Photoshop or so. You can check if the pictures are equal. If you loaded the picture before and have to load it again, then you can compare if the pictures are equal. If you have an old picture, an outdated picture, and there has been a change on the external picture, you can compare the size. But please don't trust the size. If you use bitmap pictures, the new function equal pictures returns 0, so it doesn't help you. JPEGs, it will also not help you because the same picture and different compression rates will have different sizes. So the size is not good here. And the third case, you have the same size but different content. Yes, it's possible. And you can calculate a mask, and if they're all black pixels, then the pictures will be equal, and some pixels are not black but white, the pictures will not be equal. It's too complicated. Equal pictures returns a function result, true or false. And rely or trust the function results. If it returns true, the pictures are equal, you do not have to reload it. If it is false, they are not equal, you have to reload it, or any other conflict management. And again, use semaphores. The next, maintenance and security center improvement. With v13, you now can explicitly compact the address table. This was possible maybe in 2004 or before, but you never know when it was done, because it was more or less automatically, depending on internal values, how much records in my database I have deleted. So you only knew that it was done when your sets are no longer valid. And to avoid this, we stopped the compaction of the address table with v11, and with v13, we included the compaction if you need it or if you want it, and if you control it. So only then you know when you have done it and you can react. Normally in a new created data file, you have all records packed side by side. But also in a new data file, you can have holes inside the data file or between the records, because 4D stores records in blocks of, for the moment, 128 bytes, but don't rely on this number. It can change in the future, or it can be optimized. And because of the dynamic of fields with dynamic size in 4D, like pictures, blobs, and text. One record can fill 1 block, or 2 blocks, or 3, or 1.5. And so you have holes. You have a fragmentation. You also can have a fragmentation in a fresh new database. And it looks like this. Records side by side. You have an address table, no holes in the address table, and no mess in the pointers between the address table and the records on the disk. And the current selection over there, and a nice valid set, working with the record numbers. And in daily work, you create new records, you modify records, records can shrink and grow, or you can delete records. And all this leads to more fragmentation, more holes. If you delete a record and create a new, and this record will fit into this hole, it is stored there. But if it is bigger, it is stored at the end of the address table. It's very easily told, it's a bit more complicated, but it's enough for now. And so holes are produced and data is fragmented, and then it can look like this. If you now compact the address table the old way, you have no more holes here. All the records are again packed side by side, but the address table is not compacted, and you have a mess between the pointers. And so long accessing times for the records. And bad speed, maybe. And compacting the address table the new way, the same as before. Now the address table is as small as possible, optimized, no empty elements, no mess between concerning the pointers between the address table and the records on disk. And again, very fine, but the sets are no longer valid. Why? I told you before, because the set use record numbers, and now the record numbers have changed because of this compaction of the address table. So no more valid sets and no more valid backup log files, but it is easy because you know now I have compacted my address table. And now you also know my sets are now no longer valid. And also the backup log files. So you can recreate your sets. And you start with a backup by new from now. And you have to think, is it worth to have speed or not? To decide if you compact and create the sets by new or not. And a small sample for this. Also, in this sample, we have a very simple structure with some nodes, text field to get big records, to get a big data file. And we have already... Okay, my fault. But then I have to tell you some things out of my life while we will create the records. I copied the wrong sample onto my desk. Normally, the records will be inside. The sample that you have on your, I don't know, do you get a USB key or what with the samples or the session notes? Or only by, yes, a USB key. All of my samples are on the USB key. You will find the slideshow on the USB key. And you will find a Word document where there's a step-by-step description how to reproduce the samples. that you can, at home, play with the samples, and you must not wonder how it works. So, okay, I think I will stop it here. Normally, I would have... okay. This one, yes. Save and finish. Okay. Restart once to get a clean cache. And now we have nearly 1 million records, 870,000. And I have a method that searches some things inside these records. And you will see a time about milliseconds here, about 4 seconds. Yes? In a new created database. If you do it a second time, you will see if the cache is warm, we have 400 milliseconds. 10 times faster than before, if the cache is warm. And this is a new created database. And no fragmentation or records packed side by side. What we will do now is we delete some records, maybe from there to the end. And if this is done, we will restart the application to get a clean cache. And do the search again. And you see, much more faster than before, 1 second. And with the warm cache, we have not much faster. And about 1 second. So it is not much faster because of fragmentation. And what we do now is we want to compress the data file. And you see the data file has to be compressed also because of the yellow warning sign over there. And we compact, advanced, and simply compact like it was before. Okay. So that's it. We want to restart the old way compacted data file. And to clear the cache, restart, and then we can try the search method again, and we can see what it helped us concerning the performance. So much for the moment. Yeah, okay, but he wouldn't quit before the compaction has ended. So let's see what happens with the search time now. Nothing changed, but the data file is smaller now. We had, I don't know, a gigabyte before, and now we have some megabytes, 100 megabytes or so. And the same time, okay, the cache is not yet warmed, but the same search times like before, with the old way of compaction. So where's the problem? The problem is not the compacted data file. The problem is the not compacted, or in other words, fragmented address table, record address table. Because all of these empty elements have to be, 4D has to look into the empty elements if there is a record for this. And if no, the next. There are so much unused comparisons that makes it slow. Okay. What to do? To use the new way of compaction, compact address table. Okay. So, much more faster this time. And we'll restart. Okay, maybe. Yeah, shit can happen. Okay, you have to trust me that now we are back in the search times for milliseconds, two-digit milliseconds for searching. It's a pity, but it can happen that it crashes. So the point is simply, like I said to you, think of it, if you need the speed, you have to recreate your sets, and you have to trash the old backup files and to get to start with a new backup. And if you don't want to trash your sets and your backup files, you cannot have the speed performance, the lag, and the performance boost, and you have to work with your old, with your uncompressed address tables. So how much time is left? Okay. Let's next start with the XPS. Over there. XPS. Let's start with the Macintosh. XPS is only Windows. Before OS X, in times of OS 9, OS 8, and before, there has been a print preview coming from the Altura toolbox inside 4D. Since OS X, PDF belongs to the system standard as preview, and also we use this print standard with 4D. It is native, coming from the system, and is a standard for all Macintosh applications. Under Windows, it's a bit different. There is no PDF creation integrated in the operating system. You can install a printer driver. Currently, we support the PDF creator. It can be installed under Windows, and then we can use it to create PDFs. We can control the PDF creator from inside 4D by commands like print settings, or not print settings, set print options. Under Windows, there is a, I will say, standard named XPS coming from Microsoft. It's standard for several Windows applications, and yeah, this line I have written twice. What is XPS? XPS is an XML paper specification. XML is more and more modern in all parts of computers. It is an XML-based paper description language with a vector-based format like SVG. It is device-independent, originally developed by Microsoft, and in between standardized as ECMA 388, or also under the name OpenXPS. Which Windows systems does support this? Windows 7 and Windows 2008 Server, or also R2, as a standalone XPS viewer application. If you use Windows Vista, it is hosted as the viewer application is hosted in the Internet Explorer. There's no other way on the Windows Vista system. And like I told you, Windows XP or also 2003 Server, it's too old. The there's normally no chance to integrate it in the system easily, but you can install the .NET Framework 3.0, and then it is, you can view the PDF file, the XPS file, sorry, also in the Internet Explorer. But the question is, will you on a customer's computer install .NET Framework? Don't know. Therefore, I said before, some things are normally not supported under this old system XP. And let's have a look at a sample. So here we have a list box with information of some countries, and if we want to print a preview, we simply press this button. It does not matter which printer is chosen here. I don't know if you can read it, yes. It's a use Mac printer. It does not matter which printer is assigned here. We simply said OK in the page dialog. The print preview is activated, like you can see here. And if we print, yes. Remember that I started 5 minutes later. So, and we get, this is the XPS viewer application under Windows 7. And now we have the document over there. No PDF, but an XPS. And you can scroll over there, multiple pages. You can use the Zoom slider over there. Or you can use only to view one page, or, sorry for this is in German, or to have a full screen, or something like this. Yeah, very nice. Not, and you can also print it, and so on and so on. But you also can search. Nice. Okay, the same in a PDF document. How does this print preview work? Before OS X, the Altura Toolbox print preview was generated in main memory, and you could decide, I want to print or not. These are old times. This is not possible with PDF under OS X, and it's also not possible with XPS under Windows. You will print the whole document onto the disk. PDF and XPS under Windows, the same. And if you have done this, then it is opened in the view application, with the preview application on Mac or with the XPS view under Windows. So if the customer wants to see the first page of a 500-page document, there is no chance. With this easy way, all 500 pages are printed, the viewer opens, and you can say, oh, no, I don't want it, I trash it, I will not print it. But it's the same with PDF on Mac. Now, 4D works the same with different technologies on both platforms. The documents are stored in the user folders, in the app data folder under Windows, or the local settings folders under XP, and then followed by a special folder, a folder print preview, folders named from 1 to 9, with a UUID folder inside, and then a document named document 1, 2, 3, or what else, XPS. And these documents are, like I said, device independent. You can take these documents and print it on every Windows machine, on every printer, and they all look the same. And what can you do if you want to change the name of the document? The standard name for the printer queue, that also is displayed if you have a printer queue. If you have a look at your printer queue, and it is also displayed in the XPS viewer title bar, and you can set it by set print option, spooler document option, like it worked before in 4D. There are some new commands that you can set the print preview by programming. You can elaborate if the print preview has been set by the user with a get print preview function. And while you are printing, you can find out if you are in print preview now, with the function is in print preview, returning true or false. Pros and cons. A big pro is no more license problem, because there are license problems, especially in Germany. I don't know how it is in France. You are not allowed to deliver a PDF creator. The PDF creator has to be installed on the customer side by him, or you go there and do it. Yeah, that's the big pro. And cons, so you have no chance to only print one page, or you have to handle it by programming, but it's the same now as you are working with, like you're working with PDF under Windows. And which products from 4D will support XPS? Of course, 4D, QR, Quick Report Editor, Label Editor. No 4D Draw because it's dead. No 4D Chart anymore because it's deprecated. And no 4D Write and 4D View. This is a pity, but how can we do this with a little trick? I will show you my last demo today. Yes. You see, no more crashes here. I want to start my print method. Print preview, I think this one. Okay. Print preview. And we print the XPS, and what you see here, we have a 4D write document. And over there, we have a 4D view document. And how have I done this? Very, very easy. Make this a bit normally bigger, yes? So, yeah. All records, nothing new. The preparation of printing. Your off-screen area for 4D write and your off-screen area for 4D view. Then I open existing documents lying on the hard disk. Print settings, open printing job to switch on the print preview. And if the user closes the printing dialogues, excuse me, once more. Print settings to get the dialogues. Then the new command, open printing job, 4D open printing job. All settings we have done before, manually in this case, or by programming before, calling this command, are valid for the whole print job. And it does not matter what you print inside the print job. And in this case, we print with the 4D write print command or the 4D view print command inside the 4D print job. And then I close the print job, delete the off-screen errors, and so a very easy way to print for the write and for the view printouts as XPS. Also, if the single products are not aware of this. Okay? Questions? Last minute. 1 minute of questions. Yes, please. Yes, exactly. Yes, I think I know what you mean. The question was, I think the question was, if I understood it correctly, is there any chance to have a look at the document before it is printed? Really?
Not really. I see XPS standard, okay, that's great. But my question is it is recorded on our disk. Where can we make a PDF file after it? XPS is very practical because it's cross-platform. But
Yes.
if I want to send it by mail, for example,
yeah.
we have a preview. It's great for printing, direct printing, but for mailing or anything else, I mean, for example, Linux users.
Yes, I understand. Normally, this is not the extension, the goal of XPS. The standard is send a PDF document by mail. This is the standard. Everyone is working this way. But you also can send your XPS documents, and the other side has to open it with the XPS viewer. So, in other words, you cannot send it to a Mac, it is not readable. But you can send it to every Windows and it is readable. It's not the goal. If you want to do this, do it by PDF Creator like before, under the Windows side. Any other questions? Merci beaucoup.